Hello, everyone, and welcome to the April session of Doctor Integration. This month, we'll be going over error handling in TCI Connect. My name is Jeff Leviton. I'm a customer success engineer with TIBCO, specializing in TCI. All right, we have a standard disclaimer. Let's have a review of the agenda. We'll start off going over how notifications work within TCI Connect. Then we'll go through the flow of an application execution, looking in details how it interacts with the agent and iPass, as well as the way that it walks through the different flows. We'll go into a detailed analysis of the anatomy of a flow so you can understand how the different blocks work together, as well as how the looping and operations work. Then we'll take a detailed look at the different types of errors that you can encounter. These are broken down into fatal errors as well as record errors. Then we'll give you a flowchart on how to do custom error handling, and we'll cover how the standard default error handling works, as well as the options that you have for custom error handling. And then we'll look at a flow to give you an example of how to implement some of this custom error handling. So notifications, they're configured via TCI under Environment and Tools, Notifications. And there's a separate set of notifications for each organization to which you belong. So once you have become a member of an organization, once you have been invited to an organization, you'll be able to manage the levels at which you want to get emails from that. Now, this is going to be sent to the email that's associated with the account. So even if you're using single sign-on, there's going to be some email which is ultimately tied to that account, and that's the email that it's going to be sent to. Now, the notifications are individual for each person, and there's no way for an admin or anyone else within your TCI organization or anywhere else to manage your particular set of notifications. So you have to go in there and manage those yourself. And there are 5 different triggers that you can configure into the notification screen. We'll take a look at that real fast too. The first one is probably one of the most important ones, and that's run if the run fails. And what does that mean? Well, that means that there is a fatal error that occurred when you had an on-schedule integration. And when we talk about TCI Connect, there are a couple types of integrations that we're talking about. We're talking about on-schedule integrations, and this also includes replication services. And then we also have event-based integrations, and these are triggered when a call is made to a REST endpoint. Another trigger, so basically the 2 different types of integrations you have, either what we'd call traditional batch on schedule or event-based. Each of those gives you a switch to be able to get notifications if something fails. The other way you can get notification is if during your integration process you have any row errors, and we'll talk about what those look like in that section. Another option for a trigger is agent heartbeat. Now, what is the agent heartbeat? Well, from the architectural point of view, TCI Connect, each application has its own agent associated with it for the cloud agents. And then for on-premise agents, you would install an on-premise agent on your infrastructure. And then you would manage that yourself versus us managing that agent for you in our cloud infrastructure. Now, that agent is in communication with our iPass. It's constantly syncing, it's phoning home, it's checking to see if there are software updates, it's communicating and sending information back about execution history. It's also getting new information from the iPass. Anytime you save a flow, it gets synced to the cloud, and then it gets synced to the agent. And if you have that installed on some infrastructure that agent can't communicate to the cloud, then it's not going to be able to ultimately execute integrations. Agents themselves, on-premise agents themselves, will be able to run for a small amount of time without connecting to the cloud, but it is such an important thing that if the communication breaks, then you want to have a notification for that. And why would that happen? Well, you could shut the machine down that it's installed. There could be network errors, right? There could be a process hang, all the typical things you'd run into when you're managing your own servers, and either the process is unable to, the process didn't start up on a reboot, the machine's down, or there's some type of network error. Those are the most common things that we see. Sorry. Another trigger for getting email notifications is if a connector is installed. And this is your typical thing that's done in the marketplace for TCI Connect. So within TCI Connect, it's different from Flogo in that you have to activate the connectors in the marketplace. And that's because those connectors end up getting deployed and installed on all the agents that you have within your organization. So you can also set this up that if someone does install a connector in that organization, you can get an email notification for that too. Let's head over to TCI and see what it looks like. So once you log on, you'll go over to integration apps, and this brings you to the master page of all of the assets that you have within TCI. And these include Flogo, Connect, and BusinessWorks. So to access the notification, head over to Environment and Tools and go into Notifications. And then from here, you can see these are the different ones that we discussed, right? A run failed. This is for both on scheduled and replication services. Event is for event calls. If there's any record failure, if you have an agent heartbeat or if the connector install happens, then you will get notifications based upon that. And that's really the first line. The first thing you want to consider when you're looking at how to handle errors is what level of notifications do you want, right? So I think the biggest one that you want to think about is what happens when a record fails. If I would probably say that you want this one's kind of optional. This one's a nice to have if you have a connector if you want to know if a connector is installed. Quite often you're the one that's doing it. So this would, if I went over here and I went over to Marketplace and then I deployed a new connector for this organization, then I would be able to go and I'd get an email for that. Otherwise, the ones for the notifications for failures, these are probably more important. And you just want to decide here if you want to get record failures or not. And this will give you an email after the job if any of the records have failed. Okay. So how does an application work when it runs? So what happens is the agent will start the application process for an on schedule or a replication. That's going to be triggered by a timer, or you can also trigger that manually within the UI by selecting run. Otherwise, the event is going to be triggered by a call to the endpoint in your typical REST fashion. Once that application starts, it actually looks at all the connections that are associated with that particular app. And that goes for all the apps in all of the flows. So it's quite possible you could have, your first flow might have a couple connections. Your second flow might have connections, C and D. Your third flow might have connections A, F, and G, right? So what it does, it looks at all the connections that are being used in this particular process, and then it goes through and it executes an open connection for all of those. Now, what is that going to do? That's going to go and test to make sure that the connection is still valid, right? Depending on the endpoint, that you might log on. If it's a file, it might test the existence of the file. If it's a database, it might log on to the database. If it's a Salesforce or something like that, it will make sure the credentials still work. So it does whatever it needs to do to validate that the connection can be open, and it executes an open connection on that to get ready for the integration to run. And this will occur in parallel for performance reasons, because sometimes it will take a while. And when you think about how these jobs run, this is actually going to be a little bit of a, if you think about it from an analysis of algorithms in a big O notation, this is a constant that's essentially added to the beginning of all of your applications when they run, is this open connection process. Basically, just simple initialization, but it's good to know that it's good. You have to understand that that's what happens. And if there are any failures on this open connection, it's going to result in a fatal error, and the app will exit, and it will not even start to execute any of the individual flows. Once you've gone through the open connection and all the connections are validated, then the flows run in order. And those flows will, if any fatal errors happen on those flows, we'll talk about how you can get those fatal errors. the flow will itself will exit, and then it'll actually exit the application with that fatal error, and it will skip all the rest of the flows in that particular application. Otherwise, the flows are run in order that's specified in the UI. Right. Now, what does the flow look like? Well, the typical flow we have here is we have a query block which will retrieve an array of records. This is a typical batch type of integration. For REST integrations, there's just a single record that gets processed. Then it will loop through all the records. It will have a combination of read operations as well as target operations like an upsert right here. So pretty straightforward in terms of how this works. There's looping, there's operations, and each one of these is a sort of a separate function which is executed against the connector, and that's how the flow works. So data comes in and out. If it's a read operation, it's going to retrieve data, and if it's a upsert operation or change, delete, merge, those type of operations, those are all done also as functional, in a functional way against the actual endpoint connector via the connector. So how do you get fatal errors? Well, you'll get a fatal error if on the job initialization, any of the connections fail to open. You'll also get a fatal error if the flow itself in the query block, there's some type of error in the query block. Because if you go back to the anatomy of a flow here, you think about what's happening, this is retrieving an array of records. And if something happens in this here, like, say there's a network timeout or something like that, what ends up happening is the flow has no way to recover from this. Now, the connector itself will implement retry logic under the hood that you don't necessarily have any control over. So there's a lot that's done for you in terms of a layer of abstraction between this core logic and what happens in the connector itself. So in this case, if there is some type of error in the query operation, and what could that look like, right? Well, that could look like potentially, say I'm querying a data source and I want, first name, last name, email, and status, and somebody deleted the status field. Well, that's going to return an error because that field is missing. That's going to be a failure. It's going to be a fatal error because it fails. Other things that could cause fatal errors are if you have 90% of the records fail. So what happens is the job starts up and it retrieves this array of records and starts looping through them. And then, when you're first making an integration, sometimes you'll just have some logic error where every single record fails. So instead of continuing to process, 10, 100, 1,000, a million records, it will process the first 250 records. And then what it does from that point going forward, if at any point you get a 90% failure rate, so if you process 1,000 records and 900 of them fail, that's going to fail the job itself. This is something that's built into the core as sort of like a fail-safe mechanism, right? Because you don't want these things to continue to run away and get out of control, continue to write errors. The assumption is that there's some critical error in the code that you didn't account for, so we're going to stop that, right? Other times you can run into fatal errors are if there's a function evaluation, sometimes a data mismatch, or if you're using a lookup on a lookup table, it's quite possible that you're specifying a CSV lookup and the parameters for that function return a completely invalid result. That can also result in a fatal error too. Sometimes that will result in a row error, but sometimes that'll also result in a fatal error. Of course, other times you run into fatal errors. Well, they just could be bugs, right? Sometimes in the connector, maybe there's a parsing issue. What we've seen is in some cases we're expecting JSON or XML coming back from the endpoint, but we end up with like a generic 401 or 404 error, and that's not trapped correctly, and that'll show up as a bug. Or sometimes it's just other bugs in the system, right? So those will show up as errors, but those are much more rare than something like connection. Why would the connection fail? Well, did someone change the password expired, things like that, right? So row errors or record errors, think about that there's a level of abstraction between the connector and the core. The core is really the the primary engine of integration. And that's what I think of when you see this. This is kind of what I think of as the core. And each one of these will pass off the data to the connector. Each one of these will do a lookup. And this is essentially, if you think about what this is, this query, just like a SQL select statement, right? This lookup and these fetches, these are just select statements that go against a particular data source and bring back a set of records. And this upsert, these upserts are going to be, change, deletes, merges, upserts, things like that. So there's a level of abstraction between the connector and the core. And in fact, when the core sends data to the connector itself, it's not even aware what the actual endpoint is. It's just sending out, it's just putting inputs into a function, and that function is going to do what it needs to do. It's going to convert it to API calls on Salesforce or SQL calls or file writes, depending on what the endpoint is. Right. And there's a couple different types of operations. There's read and there's action operations, right? So read are going to be the queries and actions are going to be everything else, right? So the row errors come from the connector operations themselves. So you'll send some data off to Salesforce, maybe it's an upsert, and you'll get back something like invalid email address, missing first name, missing company, invalid key, invalid external ID, right? All those type of errors that you see. And it's important to realize that when you see these errors, we do our best to pass these errors directly back up from the endpoint to the core itself, and that gets recorded into the execution history. So what happens is on a record error, the job will advance to the next record in the array. So if say for some reason this fetch fails here with some type of error, right, and I get a row error here, or the subset fails, it actually will go, even though I'm on an inner loop and I might be processing like 10, 20 tickets, if one of these upserts fails, it actually goes to the next top level record in the top level query array, right? If we look at this particular flow here, it's a pretty common pattern, right? We query some parent object. We maybe do a lookup, then we query the child objects. We loop through those child objects, and we do an upsert on our target in order to put those into the target system. Now what happens is if this upsert fails, it's going to skip the rest of the records in this fetch and advance to the next one. That's important for you to understand how that works, both when you're designing your integrations, and also if you're attempting to use custom error handling, because you need to know that you can work around this by using branching and things like that. But there's some pros and cons to different design methodologies, and we'll cover that in the example. Right. So row errors, what happens on a row error, it's going to advance to the next record at the top level, and the row errors are recorded in the execution history. What happens is each agent has a little cache locally of this data, and then what it'll do is it'll sync it back up to our cloud, and then when you go into the cloud, you'll be able to see the execution history and the errors that are associated with that. Right. All right. So let's spend a little time looking at this here. So for every operation, and each one of these, going back here, we can see each one of these is a block operation. So we'll just think about something like an upsert here. Every operation has an error handling tab, and there's two ways to manage it. One is the default error handling. And when you go into the tab, and we'll see this when we get into the example, I'll just give you the flow now and what the options are, and it'll, I think, become more clear once you see the actual example. So what happens is every time you have a function call, the function returns this set of values that we call the result set. And the result set consists of 4 fields: the description, the error description, the error details, the number of records matched, and if the operation was successful or not. And the most important thing here is, was the operation successful? All right. Now, if I say I did a lookup operation, I could have records matched equals 0, but the result success would still be true because the operation executed correctly. It's not that the operation didn't bring back any records. So when you're doing lookups, you can also use the records matched to determine how many records were returned from that lookup and then branch accordingly. Right? But what we're focusing on here primarily is the success. And if the success is false, with that, you'll get the error description and error detail. basically a short and a long version of the error. And that's a combination of what comes back from the connector, additionally with also some additional information in terms of what block, what operation was caused the failure. So you have the context in which that particular error occurred. So when you look at so everything above this red line is the default, and every time you add a block to your map, you end up with the error handling is checked, and this is the default error handling that you always get. And unless you're going to do something custom, 99 out of 100 times, you're probably okay using the default error handling. But what happens, right? So if it's checked, so what happens is once the connector returns the operation, it will return the results of that operation, and it checks to see, it will inspect to see if that has been checked. And if it has, it's going to go to the default error handling path, which is this branch up here. And what happens? Well, if it's true, it just goes to the next block. Pretty straightforward, but that's how it works. Makes sense. If it was not successful, what it's going to do, it's going to write that out to the execution history. It writes out the source data as well as the descriptions, and the source data can be used to reprocess. And it writes out the error descriptions here in detail out to the execution history, and then it advances to the next record. And this is all part of the core functionality of how it works. Now, if you want a finer control over your error handling, what you would do is you would uncheck the box for the error handling. And now what you need to do is, so now you're into this custom error handling. So what you need to do then is immediately after this block, you need to throw an if block, and that if block is going to check the value of result.success. And that's what comes out of the block as part of the return of the function call to the endpoint as part of the connector. Now you have some options here, right? One option is, in theory, you could ignore it. Well, what are they? So let's talk about why you would want to ignore it and what the ramifications are of ignoring it. Well, the ramifications of ignoring it is that you have errors that have happened and you have not recorded them in any way, shape, or form, right? So when your job is done, it's going to show 0 errors have been recorded. Now, why might you want to do that? Well, you may want to do that for performance reasons, because under the hood, these errors, if you do have a high percentage of errors, it can slow down your integration processes. It needs to record those errors. It needs to write them to the local cache. It needs to write them to the local cache on the agent, and then it needs to sync those back up to the cloud. And sometimes that if you have too many errors, that will slow down the process and then slow down your overall integration. So you may get away with just ignoring the errors, because you could have another process which will check for errors either by querying the target and seeing records which are missing. It is possible to design an integration process where you just ignore the errors. Generally, you're not going to do that, but it is possible, and you want to be sure you know you have the option. Mostly what you're going to be doing, though, is if you're going to be checking the result, and if it's true or false, you're going to be doing some type of custom operations. Most of the time, what happens is if it's true, you just skip the execution, you skip your custom blocks, and you just go to the next record. Otherwise, you could also have some custom blocks, which would most of the time it's writing this type of log file, and then you could go to the next block automatically, right? And I actually have seen people who every single time an operation is executed, they write out the data and whether it was success, whether it was a success or a failure, and this gives them a definitive log of all the records that were processed for that particular operation. And where does this log live? Well, this log ends up being just another connector that you have within your integration process, another connection, and that connection could be a text file, could be a database, could be anything, right? Most commonly, though, what's happening is if it's false, you're going to write that out, and then you may decide what the program flow is going to be afterwards. And you have some different options here, right? You could write it out and go to the next block. You could write it out and go to the next record, right? You could also write it out to the execution history, or not write to the execution history. So if you write the execution history, you will both have it in your log as well as in the execution history. So this will show up. And why do you want to do that? Well, when we go back to the notification piece, right? So think about what happens if we somehow don't fail this in the execution history, then we won't have a record that it failed, and we won't get any notification that it failed either, right? So generally, that's probably what I end up doing. You want to both write it to the log and then fail the record so it ends up in the execution history. All right. Let's look at the example to see what the actual flow looks like. Okay, give me 1 second to bring that screen up, please. Okay, so here's a flow here, which is a pretty simple flow. We're querying a company, and what we're going to do here is we're either going to create an account in Salesforce. This is a company in a little mock SQL database, and we're syncing the company objects to the account objects within Salesforce, right? Pretty straightforward integration, but let's look at the logic so we understand what's happening. So the first thing we do is we test to see if this record previously exists in Salesforce. If it doesn't, then we're going to create it, and we're going to store that key back into our source so we have these two data sources synced, right? Otherwise, we're going to do a lookup on the company, all right? And then we're going to attempt to update the company. This is the block here. So notice we have this block, and then we have immediately afterwards, we have an if statement, which we use to test to see the value of that success field here, okay? So let's look at what the configuration of this block looks like. So we highlight the block, we head over to error handling, and then we see that if an error occurs, we fail the record. So we uncheck this. Now, different block types will have different ones of these. These are two different types of errors. This is if a match there wasn't actually a match. And what I did in this case was I created a little custom text here. So this will fail if there's no record that matches. But if there is a record that matches, and then remember, that's a different type of error. There's a type of error where there's no record when you do a delete or a update. And then there's a different type of error, which is, hey, I did the update operation. It tried to find it, but there was some type of data error, bad email address, et cetera, right? So the first thing we have to do here is what we talked about in our diagram, which let's back to see what it looked like, we uncheck the error handling and to get it to our custom error handling section here. And then we inspect the value of that result.success here. And if there was an error, all right, what do we do here? Well, if there was an error, then we check the condition here, right? And the condition here we can see is update account by ID, result.success equals false. And where did this come from? When we look at our integration design in our function editor here, we see that this operation, this is the result of that operation. We get potentially fields that are fed back in, but most importantly, we have these result fields here. And what we care about is this here. So we end up with the connector, update account by ID, result success, and if that equals false, then we're going to execute this branch here. And this is our custom blocks, all right? And our custom blocks here we're going to write out to the log, and then we're going to also write out the execution history and then go to the next record, right? So the way that works is what I have here is I just have a simple text connector that's in a Dropbox. It could be FTP, it could be anywhere. And all I do is write that out. So what I'm using is I'm leveraging the platform itself in a couple ways. I'm using the custom error handling, and I'm using a connection as a place to store the log file itself. Pretty straightforward, but what this looks like here, we can see is you could imagine this is a basic type of log file. We have the date, time, the description, the detail, the entity, all the different fields that go along with it. We have a key field here. So this is basically the primary ID of the record, the number of records that got matched, and whether it was successful or not. And we could use this same type of log file for any type of thing. But this is just an example of a log file that you might want to use. One thing that we've seen people do, some of our customers do, is when some data fails, what they actually do is they write it to a custom object, say within Salesforce or CRM, and then they have the end users that goes into the workflow of the end user, and that data now that puts the responsibility back on the user to fix it. So if it's a known type of error, it's a data error, it's anomaly, right? Then what they do is they put it into a custom table that goes into the workflow of the end users, and they can go in and fix those records. And then that really helps to reduce the amount of monitoring you have to do, right? It's much better to have a push system that pushes out than a pull system where people have to go in and look at emails and then go in and look at the records and figure out what's happened. So there's a lot you can do. So the platform gives you baseline. It gives you a robust and standard way of handling errors. But because the platform is also flexible, it gives you the ability to expand upon that in whatever way you want. And so for this example, we're just writing out to a simple text file. Secondarily, what we're doing, though, is we're using the tools connector, and we're actually writing out some data to the execution history, and that's going to actually fail the row. This is something that's fairly new in terms of the ability to write out and fail a row outside of your typical error handling. And this is a nice way to combine both your custom logging with the to combine custom logging with the built-in error handling of the execution history. And then now you have it in two places. You have whatever your log file and system is going to record that error, and on top of it, you have that same data recording the execution history, and that will trigger emails if you have your notifications set up, right? So it's kind of like you get the best of both worlds in this, and you can see what this looks like from a formula point of view. Error, company ID, message, right? And here's the messages here. So I'm basically just taking the messages that I got out of that block that failed, and now I'm writing them out to the execution history using this other separate method for using the tools connector. Right? And you really should be aware of how the tools connector works. There's other workshops we have. You can check online for those about our connector extensions. And the tools connector is a connector extension. And what does it do? Well, it uses because connectors are just .NET, right? So it uses .NET to extend the function of the core itself. Because again, the core, if you think about going back to the level of abstraction between the core and the core doesn't know what the actual connector is doing. So we have connector extensions that do variables. We have connector extensions which can serialize and parse JSON. We have connector extensions called the tools connector, which has a lot of different things in it. So you should be aware of those connector extensions and check out our documentation as well as some of the other webinars around that. So then if we look back at our flow here, we see that what we did here was we went into our custom error handling because it was unchecked. We saw that the result success was false. We had our optional custom blocks that wrote out to a log. Then we did a fail write execution using the tools connector, and that gave us everything we needed to track the error both within TCI Connect as well as our external system. Right. So again, it's pretty straightforward once you just think about it, right? Every block is going to have its error handling tab on it, and then if you uncheck it, you want to be sure that you're in the very next operation is going to be an if to test the value of that, and then you go into your routine, which is going to write out to any type of write out to the log file we're storing that. One thing to remember here, though, is that for this operation, and here's where the performance comes in, right? And when we talk about performance, it's kind of a trade-off between performance and complexity of integration. So because you need to inspect the result of this block operation, you also have to go in and take off the batch processing, all right? If I were to put this batch processing on, all right, we would see that there's immediately an error that's generated here because now this block is no longer in scope because it's the delayed execution. If we think about what happens with batch processing, it stores up a queue of these records. We saw that this batch processing was particularly set to 500. So it stores up a queue of 500 records, and then it sends it to the connector. So there's no way to and then the connector will unpack that and write that out to the execution history. And we see that when we look at this, right? The key thing here is batch can be on or off for the default, but if you do want custom error handling, batch is going to have to be off, right? And that's the one trade-off that you have if you are if you're writing out your execution, if you're writing out custom errors to your own log file. So I want you to be aware that that's the one piece where there is a trade-off on that. And you're going to have to you have to design your integrations accordingly around that particular piece. All right. Okay. Well, everybody, thank you for your time for our Doctor integration session. Look forward to seeing you next month. And if you have any questions, let me know. And then we'll see you in May.